Alrighty, I'm going to do a little devlog tutorial hybrid today. I'm participating in Game Off with a friend, Randy. He's going to do most of the designing, probably all the designing, and I'm going to do most or probably all of the programming and graphics and stuff. So the theme is scale. It's for Game Off this year. And the idea here is you're going to have a good fish up here. This is a bad fish. You're going to have a good fish up here trying to get to the bottom. And this bad fish, if it runs into the good fish, it's going to eat the good fish. You do not want the good fish to get eaten. So you're going to put weights in the scale over here, and that's going to change this number. Right now, I just do that manually for testing purposes. And then that's going to create barriers. So each number has an edge collider on each edge of the number. So for example, you initiate the turn here, the red fish goes. If I click it again, that red fish can't go because there's a collider in the way. But if I change the number to something like this, now you initiate the turn again, now it can go again, etc., etc. So what I think is interesting and tutorial worthy here is how to do the navigation from cell to cell. So Godot has a great method to do this type of 2D navigation. It's called an Astar grid 2D. And that's typically used with a tile map. And there are some methods that make it kind of simple when you're using a tile map to map to the Astar grid cell. But in this case, I'm actually creating the grid based on the size of these numbers. So a number is going to have two vertical cells, as you see here, and one horizontal cell to define the navigation. And all I'm really doing here is if the fish hits a collider with a raycast 2D, it's just going to not do the navigation. But otherwise, it has the flexibility, like I could, have a destination up here and it would take care of finding a path to that location. So what we're going to talk about is how to create this so that you could apply it to any object, not just with a tile map. So this is Game Off. This is the game jam, by the way. Here's the page. But let's focus on the important stuff here. So this is an Astar grid 2D, and there's something I want to highlight here that I had trouble being sure of the first time around is this region here. So the region is the top left cell to the bottom right cell in number of cells as opposed to pixels. Now the cell size, as you would imagine, is in pixels. So this is saying each cell is 16 by 16 pixels, and we have 32 across and 32 down. And you can see this get ID path. This is where the navigation comes in. This is saying from the cell 0, 0, vector 2i0 is just 0, 0, of course. So from that 0, 0 cell to the third cell over and the fourth cell down, this is going to return a path, which is a series of cells by that numbering system. So you can see here you start off vector 2i0 and we end up at 3, 4, that destination, and these are the cells in between. Now the Astar grid has the flexibility of doing that diagonally, and there are a whole bunch of ways you can have it try to calculate that path, but the important thing is defining the grid. So there's also this get point path here, which you can see from here that it's giving you back the pixel locations as well. But again, I think this would be the upper left corner of the cell, so I didn't see a lot of use for that, but I may not be thinking of everything. Anywho, so first let me talk about the numbers themselves. I have this little scene where you just have these 4 nodes, which are spawn locations, so I can get wherever it is on the screen, like that. That's right here. So the children of that are going to have all of the locations where you want to spawn the numbers. And the way that works is each one, you can see here I add it to the number spawns group so I can get them in code easily. And then here you've got the position of 0, 0, and my X resolution for each of those number images is 245 pixels across. So I just separate each of these by another 245 pixels. That way they spawn all together. In the number scene themselves, you can see this boundary here. So I have that actually as a separate sprite, or in GIMP I just made it a separate layer to trace a little line around the outside. That way when I was testing I could drag this into the scene and line them up exactly if I wanted to. That way you don't have to zen the grid all the way through, but then if we want that off in the final game, we just toggle the visibility of that boundary. So with that in mind, this just stores all the numbers in a list. That way I can iterate over them. So if this is not the first time it's getting called, this clears all of them out of there, and then this clears the list. So then we go over here to using the number passed in, like if the scale now has however many pounds on it, we're going to get that as a string. And then we're going to spawn all of those nodes based on the number. So like each digit, the name of the scene is just 0, 1, 2, 3, or 4, or whatever. So we instantiate that scene like so, and then we add it to the tree and also add it to the list. That way, again, the iteration is there. And then we create the grid. So this is the part where we get the Astar grid 2D based on the numbers. So just to explain what's going to happen here. So again, I drew the lines in code to show the Astar grid, and also just to confirm it's being done correctly and I'm doing everything right. But that's not there by default, so I'll show how to do that as well. So the way it forms is we're going to take the upper left position of the top leftmost number, and then we're going to take the Y resolution, subtract it to get here, and the X resolution to subtract it to get here. This gives us one extra cell outside of all the numbers, and that way the fish have this little on deck position. They can be spawning in here in whatever cell. And the same thing is done in the bottom right. It's a little bit trickier to think of if you're just in the code at least. So the bottom rightmost number, which is this one in this case, in order to get the extra cell on the right, we take the X resolution and add it twice to get here and then here. And then the Y resolution, we add it 3 times to go here, here, here. So again, the X and Y, that gets us one cell to the bottom right and, creating that extra cell that's desired. So now that you see that visually, it'll be a little easier to make sense of in code. So this right here is just looping over all the number scenes that were just created up here when we were spawning them. And these are all just set to -1. These are it's just the top left position and the bottom right position that we're after here. So this just loops through, and if any of those desired positions are further left or up for the top left or further down and right for the bottom right, it sets that as those positions. That way we have the ends of it, so to speak. That whole, the region except in pixels. So the top left, like I was saying, we have the top left number X position. In this where we subtract the X and Y position to go one more square up and to the left there. And bottom right, like I said, we're adding 2 X resolutions to get from the top left corner, which is the position of the scene, at least the way I'm doing it. And then similarly with the Y, we're doing 3 because the number is 2 cells tall, so that'll get us to the bottom, and then 1 extra cell on the bottom. So the main annoyance to deal with here is that the cells in the Astar grid are by, an index number, so like 0, 0, 0, 1, etc. And I want to move the fish by position, which, the coordinates, so we have to have a way to translate back and forth. And this is where I'm going to do that. So here we're just defining the region, again, that one cell in each direction that I want outside of the numbers. I'm using this cell from coordinates method, which I made here. So what we're doing here is taking the X coordinate of whatever position we're feeding in here. Because again, we want to get how many cells to the right and how many cells down we're in based on the position. So here we're saying, give me that X position and subtract the top left X coordinate. And similarly with the Y, we're going to subtract the top left Y coordinate. So let's visualize that real quick. So we've got a, coordinate system, of course. And if I pick a point, and let's say I pick the point here, then I'm this far away from the edge of the screen, or the 0, 0 point of the screen, it's up here. And same thing for the Y, you're really that far away. So when you're getting like the global position, it doesn't care about your grid. So to account for that, I want the starting point to be my grid. So you take this position and subtract the X coordinate, and then you'll get this distance. And then the Y coordinate, you'll get this distance. So that's what we're doing here. We're subtracting that X of the top left position and the Y of the top left position in order to get how far into the grid we are in both directions. And I mentioned here I added this +1, so like if you're on 0, 0, if you're right on the boundary, it was not always getting the extra cell that I wanted. So this is just to make sure we're in the cell. And again, precise positioning is important if you're not using a tile map and doing it this way. So again, think of the boundaries around your graphics if you're going to do that, so you can position everything perfectly. So now we know in pixels how far into the grid we are. So since each cell is, that X resolution wide and that Y resolution tall, we're just going to divide that number of pixels into the grid by those resolutions, and that will give us how many cells we are into that grid. And then that gives us the ability to say, okay, now I can pick the cell in the Astar grid 2D. So back up here, so again, picking the grid top left that we've established after subtracting up here, that's going to give us that top left corner. This is going to give you 0, 0. And then the bottom right will give you however many far over you are based on how many numbers you have. Cell size, of course, we're setting to the X and Y resolution. And the diagonal mode, I don't want in this case to have diagonal navigation. I mean, we may not even have L-shaped movement in this particular game, but yeah, I definitely don't want diagonal. So this, you can set that mode. This is part of the Astar Grid 2D options. update has to be called anytime you're doing an update to the grid or creating the grid. So now we've created the grid. So now we have to talk about the navigation for the fish. It's going to use a lot of that same methodology. So if we go over to the fish, the important part is this ID path, and it's just an array of vector2i's. That's going to store what those get ID path methods will return. So it'll be all of the cells within the grid that I've just created that are going to be the path to the destination. So the fish facing direction, obviously that's going to determine where they're trying to get to. I just store that as a vector2i here, like so it starts off as 1, 0 for right. So this is basically going to be like, think of a cross and the number 1 pointing in up, left, right, or down. And we're going to multiply that by this raycast length. Now the way that works is the raycast length is enough to go, about this far, enough to get into the next cell, but not hit the other side of the cell. And then if it hits one of those colliders that I have on each edge of the numbers, then it's going to say, hey, I'm colliding. Let me just show that. So on the fish, I have this raycast 2D, and here I have these properties on the script which are exposed, and I can adjust it here. So the target position, it just starts off as whatever, but you're going to set that in code, so this won't really matter. And here you can see this is, reaching out yay far like I want it to. So this is just an event I have that's being fired off from the level script. I just define an event, and that way whenever that event gets fired, it's going to, notify that script. So right now it's just when that test button is pressed, but eventually when you put weight on the scale, it's just going to fire that event off. And that's when we say, hey, fish, move fish. This gets that raycast because we're going to need that. So here in the move fish method, we're saying if the number detector is colliding, that's that raycast, don't do anything, so it can't move. That's pretty simple. Otherwise, we're going to, get the navigation path. So the current cell, so if we go level cell from coordinates, again, that's that same method we talked about before, where we pass in the global position, and then we know what cell that fish is in right now. That's going to be the start of our navigation. So in the destination cell, we're going to get the current cell plus the fish facing direction. Now, why does that work is the next question. So remember, the fish facing direction is just going to be a vector2i that's going to be 1, 0 or 0, 1 or the negative versions of those. And remember the region right here. Remember, this is a number of cells, and each cell is just iterating by 1. So what we can do is use that vector2 to say, 1 cell away from my current cell. It's just going to be pointing to the next one in this grid too. And that's why we need to separate the raycast length. We multiply that when we're looking for the actual coordinate position, but that fish facing direction is just going to be a unit vector, so we can move to adjacent cells. And you could put this destination cell anywhere in that Astar grid 2D, but right now I'm just interested in getting to the next cell. So that gets us to the adjacent cell. It's always going to be one at a time in this game, at least. So this is that method we saw on the documentation page. We're going to get the ID path from the current cell to the destination cell, however you want to determine that. So this slices the first item off the array. So you don't want to count the cell you're already in as part of the navigation path. So right away, chuck the first element of the array, and this is just debugging, and I set moving to true. So while moving is true, down in the physics process right here, I guess if moving technically, as long as you have any items left in that ID path, any cells left to navigate to, you're going to set the target position to the whatever the first element right now is in that ID path. And remember, this is just going to be in the cell position, like the cell index numbers. So like 1, 2, 2, 2, not the coordinates, because that's what that method returns. So now we need to get the global position that we're moving towards in coordinates. We're going to do global position move towards, and then I have this coordinates from cell, which is going to undo what we were talking about before. That way we get the coordinates. So let's look at that. So to keep it simple, let's pretend we're in cell 1, 1, and we're passing that in. That'll be, a vector2i again. So the grid top left x, again, this is the coordinate position of the top left corner of the grid, plus, so in this case, 1, 1, if the cell's x item is 1 times the x resolution, then we're going to go over 245 pixels from the grid top left. And same thing with the y. And this is all just relative to the Astar grid 2D because we're passing in a cell from the Astar grid 2D. And we're resolving that back to where we are on the screen with these variables, because these are the coordinates that determine where on the screen the grid is. So again, like I was saying, this is going to get us to the top left position of the cell. but we don't want that. We want the middle. So we just add the X resolution divided by 2 or the Y resolution divided by 2. That'll get you halfway into the cell in both directions. So now we have the actual global position that we want to move towards. The move towards method is just going to look for the screen coordinates, not caring about your Astar grid 2D. So that's what gets returned here. We're going to move the fish's global position towards that next cell, except in screen coordinates. And then obviously this is just the speed you want to move towards. You can set that to whatever you want. So this is saying if we've reached the next cell here, because again, we're using the same method, coordinates from cell from that target position. This just means if we've reached it, set moving to false, so it doesn't keep doing that. And then slice another item off the front of that array. So we've reached this point, take that point out of the array. And if you were doing navigation across multiple cells, it would just move on to the next one, because then we would still have more than 0 in here, and it would try to do all of this for the next cell in the array. So now about these red lines, because that helped me figure out what I had done wrong every step of this way. And so that everything I showed so far will make it actually work, but it's really helpful to be able to see this. So I'm going to talk about drawing these lines. So there's this draw method which you can override, and that's where you would draw canvas type objects. And I have, as long as you have it enabled, so I have this show grid lines which I can take off. And this lines populated, the reason I have that there is because I was having a little bit of an issue with a race condition if I tried to just have it redo the grid every single time. So what I do is I have just changing this number, get rid of the grid, as you can see there. And then when you set the number, it recreates the grid based on just this one number in this case. This is how we draw the grid lines. It's one of those things that's simple after you do it. This is just going to loop over every cell in the X direction, and within that, every cell in the Y direction. So again, to mentally visualize that, we're just doing in a loop, we're saying for this cell, go through all the Y's, and then go to the next one, go through all the Y's, etc. It's going across like that and iterating over each cell. And a lot of this is the same logic we had talked about before, where we're starting with the top left of the grid and then adding however many, except in this time resolution, because we want pixels this time, times I, which is the X, the number of X cells over we are, essentially. And then same thing with the Y resolution, and N, which is the number of Y cells we are down. So this gets your upper left corner of each cell as we're iterating through it. And then, you can, in some cases, the X and Y are the same, which is why I just set it to each other here. But, you can see here that's just going to get the 4 corners of each cell. And then this draw line is just part of Godot's canvas drawing methods. All it is you just give it a starting point and ending point, color and thickness, whatever. So this is the hard part. Once you get through that, then you just draw the line from the coordinates that you got, and it'll draw a line around each edge of the cell.